Hey everyone. In today's video, I'm building a full stack to-do app using just HTML, CSS, and JavaScript for the front end, and AWS services like Lambda, DynamoDB, and S3 for the backend and hosting. We'll use serverless architecture, which means no traditional servers, just fast, scalable, event-driven services managed by the AWS. Let me quickly show you how the app works. We can see a login page. Let me log in with my credentials. Yeah, we can see the my task dashboard. Here we can add a new task and we can see on which state the task is on. We can add any number of tasks. We can add a task with a title, description, and choose the status like current, in progress, or completed. Once added, the task is saved and configured accordingly. And hosting with AWS S3. Um, the S3, we are hosting our front end using Amazon S3. S3 is a simple storage service where we can upload and host our static files like HTML, CSS, and JavaScript. Here, what I did created a new S3 bucket, enabled static web hosting, uploaded the HTML file, set index.html as the entry point, made the bucket public to access the app with URL. And now our front end is live. Step 2 is configuring the database. We use DynamoDB to store our data. To store our task permanently, I used Amazon DynamoDB, a fast NoSQL database. I created a table named tasks. Let me show you that. Here we can see. I created two tables. One is for task and another is for login page users. Uh, yeah. Uh, ID is unique for the both of the tables. So this way, every task is stored and can be retrieved or displayed later, even after refreshing the page. And next one is Lambda function. Now let's talk about the core of the backend. AWS Lambda. Lambda lets run us backend code without any servers. I created a Lambda function in Node.js that receives task data from the front end, saves it into DynamoDB, or retrieves existing tasks and sends them back. This function is triggered with an HTTP API. Let me show you the API. Open in your chat. Yeah, there you go. Yeah, here it is. To allow our front end to communicate with Lambda, we use Amazon API Gateway. It acts as a bridge, exposes our Lambda function as a REST API, supports GET and POST requests, handles things like course, headers, and security. Once the API is created, I copied the endpoint URL and connected it with the JavaScript fetch calls function. Mm, I am role. Let's see I am role. Here we can see a new role created here. For the Lambda function to access DynamoDB, we need to give it permission. I went to the IAM console, found the execution role for the my Lambda, attached the Amazon DynamoDB full access policy for development and testing. Now Lambda can read or write data to DynamoDB securely. Yeah, maybe network switching. Now everything is connected. The UI is hosting on S3. Socks are sent to Lambda with API gateway. Lambda stored them in DynamoDB. When the API loads, it fetches and display tasks from DynamoDB. No servers, no frameworks, just clean code plus AWS is used in this building the application.